Hello, my name is Professor Ajvan, and this is episode 8 in the Quadratic series. In this episode, we're going to be talking about how to factor a quadratic when a is equal to 1. A is the number in front of the x squared, meaning that there's no coefficient in front of the x squared for this episode. Next episode, we'll look at when there is a number in front of the x squared. So the three examples that we're going to look at in this video are on your screen now. If your homework problems look like these, then this is the video for you. If you're looking at these problems and you think you already know how to complete them, I would suggest going to the next episode in the quadratic series. For everybody else, we're going to go ahead and jump into it. First of all, what is a factor? Well, if we think of a number like 24, a factor could be thought of as any two numbers that multiply to make that number. So two factors for 24 could be, well, 1 and 24. It could be 2 and 12. It could be 3 and 8. It could be 4 and 6. And we could write these typically as the product of the two factors. The other thing that I want to make sure we understand is quadratics are written in this standard form of a x squared plus bx plus c. So the a in this video is always going to be 1, but we're going to have numbers for b and we're going to have numbers for c. So if I say c, I'm talking about the constant term, and if I say b, I'm talking about the coefficient in front of the middle x term. Okay, with that out of the way, let's go ahead and look at our first example. X squared plus 11x plus 24. The first thing that I want us to do is look at the c term. So we want to look at this constant term, 24. And we want to ask ourselves, what are the factors of 24? Conveniently, we just got done listing them. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. We're then looking at these factors, and we're looking for two factors that add up to make the b value. So my b value is 11. I'm looking for two of these factors that add up to make 11. Well, 1 and 24 gives me 25, 2 and 12 gives me 14, 3 and 8 gives me 11. So we're going to use this 3 and this 8. The way we're going to use it is we're going to, instead of writing 11, we're going to rewrite it as 3 and 8. So we take our b term and we break it apart into the two factors for c that add up to make that b term. Once we're here, we can recognize that this is now a polynomial with 4 terms. If you haven't watched the previous episode already where you learn factoring by grouping, I would recommend you go watch that video before continuing this, because that's what we're about to do. We're about to factor by grouping. We have a polynomial with 4 terms, which is our hint that you should factor by grouping. So we draw our imaginary line, and we look at the two terms on the left, the x squared and the 3x, and we ask ourselves, what's the greatest common factor between x squared and 3x? Well, the greatest common factor is just an x. And what are we left with? We're left with an x and a positive 3. What's the greatest common factor between 8x and 24? Well, that would be an 8. And what are we left with? We're left with an x, and we're left with a 3. Because this x plus 3 and this x plus 3 are the same, we know that we've successfully factored by grouping, and we can go ahead and write our final answer by having the two things that are the same be one factor, And then the two things that were pulled out as a GCF, x and positive 8, are the other factor. So x plus 3 times x plus 8 are the two factors that multiply to make this polynomial x squared plus 11x plus 24. So what we're doing is we're rewriting this quadratic into a polynomial with 4 terms so that we can factor by grouping. That's the strategy. Let's look at another example. In this example, I have a C term of negative 30. What are some factors of negative 30? Well, there's going to be a lot now. We're going to have positive 1 and negative 30. We can also have negative 1 and positive 30. We can have negative 2, positive 15, positive 2, negative 15. We can have positive 5, negative 6, negative 5, positive 6, negative 3, positive 10, positive 3, negative 10. When you have a negative value for your C term, it doubles the amount of possible factors that you can have because one of them could be negative and one of them could be positive. So we have this list of factors and we're looking for one of them to add up to be negative 1. So rather than add all of these up, we should be able to identify rather quickly that 5 and negative 6 will add together to make negative 1. So instead of writing this as x squared minus 1x, we can write x squared plus 5x minus 6x minus 30. And now we have our polynomial with 4 terms, so we can factor by grouping. So looking at the two terms on the left, the x squared and the 5x, what's the greatest common factor? Well, that's an x. What are we left with? X plus 5. On the right, negative 6 and negative 30. We could take out a 6 and be left with negative x and negative 5. But these are not the same. In order to make them the same, we need to not take out a 6, we need to take out a negative 6 to be left with positive x and positive 5. So now these two are the same, x plus 5 and x plus 5. So x plus 5 is one of our factors. The other factor are the two GCFs that we pulled out, x and negative 6. Of course, if you want to check this answer, you can FOIL it, you can multiply using the box method or the stacking method that I've already done videos on, and you should end up with the original polynomial, the original quadratic, x squared minus 1x minus 30. Alright, we have our third and final example. 28 is our C term. This is what we are looking for factors of. So we can list out a number of factors of 28. We have 1 in 28, 2 in 14, 4 in 7. But we should recognize that if I add up any of these, I'm always going to get a positive answer. And the B term that I'm looking for is a negative 11. So what can we do to make these negative when we add them together? Well, I need two things that multiply to make positive 28. So yes, it's true that 1 in 28, 2 in 14, 4 and 7 are factors. But there's also negative 1 and negative 28, because two negatives will multiply to make a positive. We also have negative 2 and negative 14, negative 4 and negative 7, which just so happens to be the pair of factors that we're looking for to add together to make negative 11. So we can go ahead and rewrite our quadratic as a polynomial of 4 terms, and instead of writing negative 11x, we can write negative 4x and negative 7x. And I should say, it doesn't matter what order you write these two in, you'll end up with the same final answer. And then we still have plus 28. Drawing our imaginary line down the center, looking at the two terms on the left, the greatest common factor is an x, and we're left with x minus 4. Looking at the two terms on the right, the greatest common factor is a 7, but we're left with negative x plus 4. So to change these signs to make it x minus 4, I need to take out a negative 7. And if that's something that confuses you, my video on factoring a greatest common factor will explain how factoring out a negative changes all of the signs. At this point, we can see x minus 4 and x minus 4 are the same, so that x minus 4 is one of our factors. X and negative 7, the two greatest common factors that we pulled out, make our other factor. And just like that, we've factored the quadratic. I do have a bonus example that I want to look at. We're going to start it exactly the same way. Negative 12. What are the factors? Well, positive 1, negative 12, negative 1, positive 12, negative 2, positive 6, 2, negative 6, negative 3, positive 4, 3, negative 4. Now that we've listed out every single possible factor of our C term, and if we add all of these together, we have negative 11, 11, 4, negative 4, 1, negative 1. The number that we're looking for is positive 7. There's no positive 7 to be found. This means that this quadratic is not factorable. A more mathematical, we'll say, way to put it is that this is a prime quadratic, meaning the only two factors of this quadratic are the quadratic itself and 1. Okay, so if you come across a quadratic that just isn't working, make sure that you have every possible factor listed and that you're showing both yourself and your teacher that, hey, none of these add up to make the B term, it doesn't work. Just don't look at it and think, oh, well, that's a big C, or I can't think of all the factors to that C, I'm just going to put not factorable. What I tell my students is if you're putting prime or not factorable, this is how you show your work. Alright, so in the next video, we're going to do the same exact thing that we did in this video, factoring quadratics, but we're going to look at what happens when A is not equal to 1, and it really just adds one extra step in the very beginning. If you found this video helpful, consider giving it a like, and maybe consider subscribing for more math lessons. If you have a question, go ahead and comment it below, and I'll do my best to answer. If you have a suggestion for some sort of math content that you want covered, go ahead and comment it down below, and I'll see if I can do a video on it. Thanks, and we'll see you in the next episode.